All right, so here on the table behind me is the aftermath of the little test, which I've been running for the past couple of days. And I'm really just trying to answer a question for myself and taking you guys along for the ride. And that is, what's the best way to get prints to adhere to your bed? And of course, we all, get a new roll of filament and we go to the internet and look up the best settings, best bed temperature, and if it's nylon, what kind of bed do you stick it to, that kind of a thing. Usually I get sent to Matter Hackers. That's usually where Google sends me. But I need to answer it for myself. I've never seen a sort of cohesive single source for bed adhesion. And this all started for me personally with my the artillery Sidewinder printer, which has a big piece of, Ultrabase. It's a borosilicate glass with kind of these little etched, they look like etched dots, but I looked them up and there's something else. Anyway, we'll talk about that later. So I love that. When it came stock, it was amazing. You print PLA on it, and as soon as the bed gets cool, the PLA isn't even stuck to the bed anymore. It's firmly stuck on there the whole time it's printing. It's not coming off. And as soon as it cools down, it's already detached. I can just touch it and it's moving. So no need to get a flexible, print surface like this piece of Garolite, also known as, G10, or I don't know, there's other names for this. Or like this, this is what came with your printer probably. If you got a Chinese printer, it's this floppy magnetic thing. These are garbage. We'll get to that. So the runner-up to the Ultrabase in my mind is the flexible steel with the PEI surface on it. But you don't need to flex your prints when you print on Ultrabase. It pops off automatically, so you don't even need to take that off and do that. You just pick your print up off the bed. It's even more convenient than this. So yeah, Ultrabase, when it's brand new, is my favorite. And unfortunately, after a while, that surface just kind of seems to lose its performance, and I wondered why. And then I wiped it one day with a white paper towel with some rubbing alcohol, and I got like a discoloration. It's like an orange color on the paper towel, and that clued me in on the fact that even though the borosilicate Ultrabase combination, that with the etching on it, even though that's a great upgrade to your original borosilicate beds, this kind of thing, where we all started back in the day. And of course, like my $3,000 printer, the most expensive printer I own, coming from E3D, still just has a regular old clear borosilicate glass on it. So this isn't like, it's not like it's gone, but Ultrabase is the upgrade to this. That's how I think of it. And yeah, it stops performing after a while, and it's because that surface treatment gets worn away or gets used up, stuck to prints or whatever. And so I really wanted to figure out what that surface treatment was, and I got a hold of this company called Vision Miner, and they sell nanopolymer adhesive. You can also get this at Matter Hackers if that's where you buy your 3D printer supplies, or you can go straight to the Vision Miner website. And this stuff, as it turns out, is exactly what the Chinese companies are coating Ultrabase with. It's the exact same performance. So I suspect that basically China is buying this from Vision Miner, putting it on all of their printers that come out the door, so we're so wowed by the performance and not telling us that this is going to wear away. So this is kind of a consumable, although if you're only printing with PLA, you hardly ever need to recoat your bed, like once in a blue moon. So this very expensive $50 bottle, that's not cheap, is geared towards professional 3D printers who are just tons and tons of prints coming off those surfaces, the print surfaces. But if it's a hobby level thing that you're doing with your 3D printer, there's a $5 sample. Go to Vision Miner's website and get the $5 sample. It's a little bit hidden, and so that's the takeaway. This nanopolymer adhesive is the bee's knees combined with Ultrabase borosilicate glass. That's my favorite print surface. And in the rest of this video, we're basically just going to do a kind of a scientific study. I'm going to test each of the surfaces to try to figure out the best way to get the most common materials to stick to it, being PLA, we got some PETG, some ABS, and then some nylon. Those are, I think, probably going to be the most common materials. As far as the other one, the flexibles, TPU, that'll stick to anything, you guys. In fact, well, we'll get to this, but it'll stick to your build tack, the garbage thing I was talking about here. It'll stick to your build tack so well that you have a problem getting off. Also, it sticks to your PEI so well that you might have a problem. So that's the other reason I love the Ultrabase, is because it is so durable. Here's your knife, right? Do that to a PEI surface or to your Ultrabase, or I'm sorry, to your build tack. You're gonna ruin it. And I think that knives have a bad rep because there's a lot of bloody pictures of people's left hands where they were holding back here, they were trying to get their print off, and it finally gave way. The print finally just popped off, and the knife kept going, and they sliced up their hand. So two keys to that. First, get a very good knife. You gotta bevel that edge. One side bevel, this side's still flat. You bevel the edge with like a Dremel tool so that it's reasonably sharp. Now, it's not like razor sharp, but that's sharp. I could cut vegetables with that for my dinner. And then the other key is to hold it on the bed like this as you slide. So you stick it on the bed and you flex it up so that it's literally like a jam sliding up under your part, and that sharp edge is able to get underneath that first layer and separate it. And of course, hold behind the knife so you don't, don't make that left hand bloody. And so that's the key. Like, a knife is not that bad, but you don't even, when you need it, you can use it on your Ultrabase. But most of the time you don't need it. If you're printing with PLA, it just pops right off. So yeah, Ultrabase, in my mind, is the best print material. Once again, I kind of beat that dead horse. Let's get into the study. We'll kind of get into all the details. And hey, stick around after the study. Talk a little bit about the history of bed adhesion, because that's kind of an interesting topic as well. All right. What you're looking at here is the first of many test prints that I'm about to do. So I've got some just very clean PEI for the print surface there, denatured alcohol that I used to wipe it down, paper towel, and yeah, so that's, I mean, we know this is going to work. We all have experience with this, but just for the sake of experimenting, I'm gonna run this test. This is a flexible bed, but I can see that this edge is, I don't know if you guys will catch that on the camera here, this edge is kind of starting to peel. So I suspect that edge would peel real easy. Let's see how easy this pops off. Yeah, real easy. See, it's popping up off the edges, and that just popped right off. Super easy. So PEI works great for printing PLA, but we knew that. Getting the PLA off the stock, build tack material is not the most difficult thing, but it doesn't just like pop right off. It definitely has to be peeled off, but it comes right off. This ABS filament that I got from Matter Hackers from WXYZ Works seems to be, maybe it's ASA and not actual true ABS, because it's sure to stick well to things without any product. So this is PEI sheet with nothing on it, no glue stick or anything, and that is quite nicely stuck down. Like, it's not, there we go. It's just that easy though. So yeah, PEI to the rescue. Pretty cool stuff. It looks like either PEI or build tack will hold your ABS prints down. You don't even need any product. Let's see how easy this comes off the bed. So a flexible bed, right? And it pretty much peels right up. Just like that. Nice, very nice. It's a little bit more stuck on there than I would have liked, but it comes right off. It's interesting. There's like a, seems like there's a residue. Looking at the test print that we just peeled off, we can see the residue here, this white that's left behind on the underside of the part. And that's just really interesting to me, because we can now see this brand new piece of build tack had never been used except for the, what is this, the PEI, or I'm sorry, the PLA print that we did a few minutes before. And look at, the ABS print stuck to it and came off it, but it also damaged it. Look on the back here. You can see that it even deformed the magnetic surface on the back. So the longevity of this is very, very short. Here we have another one that I used previously, and you can see how it got damaged as well. And I think I was using glue stick, so I had a sheet of, or a film of glue stick down on this when this damage happened. So yeah, it might work once or twice, but it's not going to last forever when you're trying to print ABS on this, the build tack that comes with the printer. So at this point in time, PEI is winning over build tack. Nylon on PEI, First layer, not even starting to print, and it's already failing. Yeah, that's known to not work. I don't even know why I bothered to test this one. Okay, nylon on glue stick on PEI stayed down just fine. Let's see how easy this is to pop off. That bed is still quite hot. I should probably wait till this is cool, but all right, that is coming off, and of course, peeling it off kind of bent it. Well, it's nylon also. It's not the most rigid material. You see, we got some peeling here at the corners, at the very corners. There's some peeling there, but that's entirely my fault. You see the pattern right here in the glue? I didn't get good glue stick coverage at either end. You see that right there? There was no glue stick right there where it peeled up. So if I had done a better job putting glue stick down, I don't think I would have had those issues. And this was not easy to peel up off the bed. So I'm confident that nylon will print wonderfully on fresh glue stick on top of PEI. Well, this is a surprise. I thought it would perform better. The nanopolymer adhesive on the PEI with nylon is peeling. This is coming off the bed quite easily, which would be nice if it stayed stuck down. It would be nice to have it releasing so easily. And once again, there's that sticky. I can feel the same sticky, kind of like a glue stick. Yeah, so I can see with the reflection there on the bed that I definitely had full coverage with the nanopolymer, so it's not my fault that that's not sticking. So I'm going to call this sheet here dead. You can see that nice permanent deformation there in the edge of it, and the place where I was printing right here with the glue stick, you can see that it's also dimpled, like it's been damaged there as well. So we got the damage right down the middle, the severe damage with the bubbles in it. There you go, you can see the bubbles. And then you have damage there as well. So what I think is going on here is this plastic is not high temperature, and 265 degrees, which is the nozzle temperature for nylon that I'm printing at, is damaging this and causing it to stretch. And that stretch manifests at the edges, and then the magnetism of this rubbery magnet is not strong enough to hold it down. Now, I do need, in fairness, I need to say this. This is from some random vendor on eBay. So it's a reproduction. It's not the actual Creality version. This is the original one that came with the printer. So I did trim it down. I damaged this one as well because I was printing too close for my first layer for a couple of times, and I would put a strip right here, just sort of a purging line at the front, and it sort of wore a groove into it, which stretched, and it damaged the whole front edge, like here with the handle. So I cut that off, and I actually cut this one down for use on a different printer. But yeah, I mean, we'll see what it does here. Even the genuine, I never thought I'd be calling a Chinese component genuine, but this is the genuine Creality one, and this is some random other Chinese company cutting corners, cutting costs. So see what it does. This is glue stick. All right, well, once again, the nylon is staying stuck to the bed here, but the bed is peeling up. So I'm gonna call this a failure. It's the bed. It's the well, this time it's peeled off the glue here has separated. So I've got the sticker peeling up off the magnet. But yeah, at least it's definitely staying stuck down. But I don't know. This is the build tack is not a good solution for nylon. There's another factor to consider with the print surface, and that is the weight of the overall assembly. So here we have the PCB bed heater with the PEI print surface, and it's coming in at 1 pound, 12.9 ounces. This is that same bed, except that it now has an Ultrabase glass print surface on it, which means that it weighs 2 pounds, 3.5 ounces. That is a considerable weight increase. And as expected, the PLA prints perfectly onto clean, dry Ultrabase. Now, hopefully this will come through on camera. Can you guys see there's a discoloration? See the yellow discoloration here on my paper towel? And it's a little bit stiff. So I have cleaned and cleaned and cleaned this Ultrabase material with my denatured alcohol, otherwise known as demethylated spirits. and I keep getting a little bit of residue. So there's just a little bit of glue left behind. Maybe it's in the textured glass. You guys see those? You see the beads? There you go. There's the etched dots in that glass. So anyway, maybe I didn't get it completely clear, but you know, it is what it is. So as clean as I can get this thing, it sticks perfectly and pops right off. So yeah, PLA, super not a challenge to print on almost any print material. But it is worth noting that I did print all of these PLA prints at 60-degree bed temperature. Well, this bed is still very warm, not quite 110 degrees anymore. And this ABS print on the raw Ultrabase material, although there is a slight bit of stickiness to that. So I didn't get all of the product off, whatever the product was originally. But yeah, this is starting to peel up. I don't know if you guys can see that bouncing. How about this end? Yeah, bouncing pretty bad. So if this part was continuing to print, that would be a failure. So even though that looks like a success, I'm gonna call that a failure. You know what, never mind. I just looked at the temperature reading for the bed right now, and it's only 65 degrees. So that bed is half the temperature that it was while printing, and so that actually is extremely nice. It printed and held onto the bed while printing, and then it released once it got cool, so it's just very easy to pop out. So actually, of all these ABS test prints, I think this one is the nicest. And there's really no evidence on that bottom of peeling. So it looks good. Looks really good. And it's just failed. So on that second layer, the Ultrabase without any product on it cannot hold nylon. All right, this bed is now 77 degrees, and that is glue stick holding nylon to the Ultrabase. And it is quite well, on that end it was quite well stuck down. This end was easier to peel up. And you can see I put a really thick layer of glue stick down because I laid that down with the bed at 110 degrees is when I applied that. So probably too thick. And on the underside we can see glue stick residue. That's very sticky. It will stick to my thumb. Also, if you look at the reflection, you can see that it's not perfectly flat, so it was starting to peel on this end. See it? Let's apply some of this nanopolymer for this test. So you basically just sort of drip it on, do whatever, and then brush it on. You see the reflection of it? You can see it drying. All right, so here we have the product, the nanopolymer, and it's clearly peeled at the edges. So let's just pop this off the bed. Yep, really easy, comes off the bed really easy, but it's warped, so that's a failure of a print, so I'm not gonna put that in the success pile. Here's a sharp knife, and trust me, that's pretty sharp. I mean, like I said before, it's not razor sharp, but it's not dull. And I can literally try to damage that, and it does not damage. So this is a very durable. If I did that to my PEI bed, it would ruin it. Okay, so this is very durable and tough. However, it's not impervious to all abuse. See that? That is a damaged section of the Ultrabase, which is weird. It's almost like a sticker or like a coating on top of the borosilicate glass. Now you can see through it. See, there's the screw hole. So I assumed that the dots, let's get another close look at those. I assumed that those dots were etchings in the glass. But now, like you can see, let's see if you see right there? See, it looks like there's some delamination. Like the surface isn't quite adhered to the bed. And of course, there's the damage. You can see that peeling up. So there is some sort of a coating there. I just don't know what it is. I did my research there on the internet. I cannot figure out what this coating is. Maybe it's some sort of a ceramic. All3P or 3dp.com or something like that has a picture of a scanning electron microscope view of the Ultrabase, so a really close microscopic view of it, but that doesn't reveal what it is. So if anybody knows what this stuff is made out of, chime in the comments, educate everyone. You know, let's get the word out and tell everyone what this stuff's made out of. All right, this PETG print is done. This is the raw bed surface. It's still a 65-degree bed temperature, and I'm having a problem. I'm having a problem removing that. So let's prop this under there. There we go. So apparently there's no product needed, so I don't even need to test glue stick or Ultrabase here on the bed. Well, I really want to test Ultrabase without, that hasn't been contaminated. So this is my, what is this? My FL Sun Q5 printer. Came with this Ultrabase bed, which I've never done anything to. I've never put glue stick on it or anything like that. So I just was cleaning it because it had dust on it. You know, it's been sitting in my room for a while here. And look at yellow, which is the same color as when I put this stuff down and then wipe that up. So at least for this FL Sun, I think that they're coating this with nanopolymer from the factory. Well, camera malfunction, so I couldn't show this thing getting peeled up off the bed, but the bottom line is that the stock Ultrabase material will hold PETG down to it perfectly. So I've never done anything to this bed except wipe it with denatured alcohol, and it's wonderful. So yeah, PETG on untreated Ultrabase is fantastic. And just for the sake of experimentation, I thought I'd try printing some nylon on this Kapton tape, and you can see I had to stop the print because it's not working either. Nylon, really hard to get it to stay down. Although, it's funny because except for the places where it's peeled, it feels really nicely stuck. So this is Kapton tape with nanopolymer adhesive on top, and it's still failing. See, it's peeling at both ends. All right, well, this is a piece of Garolite, or it goes by other names. I'll put them on the screen, and oh boy, that is a big, massive failure. Yeah, we're gonna have to cancel this. All right, so a quick internet search reveals that Garolite is a phenolic glass fiber reinforced resin sandwich, and it goes by the name of FR4 or G10, and Garolite appears to be some sort of a trademark name or something. And there's other trademark names of this stuff out there, but basically this is the substrate in printed circuit boards, and according to the internet, it's supposed to work to hold down your nylon prints, but I am not getting any success. Now, it's worth noting that I am printing with a print bed of 110 degrees. So some of those things tell me to print with a colder print surface. So I'm going to give that a try right now. All right, I'm going to stop this print. It's this is 60-degree bed temperature with glue stick, which according to Matter Hackers, this is supposed to be the magic combination. It doesn't work for me. Let's review all of these successful prints here. Now I put those in quotes because none of these nylons are completely successful. And so let's start the conversation with them. Here we have a glue stick on build tack, and you can see it is severely warped, but that's because the build tack itself peeled up off the bed, either the magnet detached from the bed or the bed detached from the magnetic surface. So I was not able to get a successful print because of the failure of the magnetic base on the build tack, just this flexible under stuff. Perhaps a build tack on a flexible sheet of spring steel, like I have the PEI attached to, that might actually be a completely successful solution, but the problem there is durability, because just look at how abused, and each one of these is a single print. So this stuff really does not last very long, and it's not easy to adhere a new print surface to a flexible piece of spring steel. So even if that works for nylon, I'm still going to say no. It's just too difficult to constantly replace this stuff. Yeah, so I don't like it. This is glue stick on PEI, and that was my most successful print, but you can still see a little bit of peeling there at the ends. And the glue stick here was very thick. I laid down glue stick on a 110-degree bed, so you can imagine, just how much glue stick dried as I was, passing it across there. And I think it was that thickness that kind of saved it, because, glue stick to Ultrabase, you shouldn't get any different performance, and it was a slight difference as far as the performance go, although looking at the actual peeling of the part, it's not too much difference. So I'm going to say in hindsight, despite the kind of comparison I was drawing during the test, looking back on it, there's no difference between these two, and I wouldn't call either of these successful. In other words, in order to print nylon, you have to use a heated enclosure. You can't let it shrink and cool down in the air. So you probably need an enclosure that's up to like 70, 75 degrees or so. So that's where that is. Basically, none of these work for nylon in the open air. There's just isn't a solution as far as my tests go. Despite what people on the internet claim, matter hackers, I'm looking at you. That was a total bust, your solution. So, but let's look at the most common filaments that most people are going to use, that being PLA, super common, awesome performance on all three build surfaces. And in fact, if you're only printing with PLA, you really don't have to worry about the longevity of your magnetic bed here, because you're not going to damage it. It doesn't get hot enough. You're only going to heat that to like 60 degrees. And in fact, you don't even need to heat your printed beds or your printer beds for PLA. It's that easy to print with. That's why we all use it. So yeah, the material that came with your printer is all you'll need if this is the only material that you're going to use. Most of us want to go on to higher performance plastic, that being PETG. And so we can see all of these were successful: glue stick, nanopolymer, or raw on the Ultrabase. And I didn't do these tests on the build tack because I know for a fact that it works. In fact, it works so well that you can't get the PETG to come off of your build surface. It's like fused together, never to come apart, unless you coat this with glue stick. And we know that glue stick on PEI works just fine. So yeah, you have to use glue stick on your build tack. Otherwise, you ruin your build tack if you're printing with PETG. And actually, it's kind of a similar situation with PEI. Now, that's also the case with PEI and a flexible TPU material. You must use glue stick or a nanopolymer if you're going to print. Don't print raw with PETG or TPU. You can damage you'll get such a great bond between those plastics and the PEI that you'll ruin your bed. So you need a product anyway. So there again, I'm going to say, okay, so for PLA, I think build tack is superior, or not build tack, for Ultrabase is superior, because when my normal parts, now you saw me peel this one off, I actually had to peel it off the bed on the Ultrabase during the experiment, because I didn't let the bed fully cool down. But if I had let the bed fully cool down to room temperature, this just pops right off. Literally, it's not even stuck to the bed anymore. It's like that. So I prefer that to the PEI, that material. And then for PETG, I prefer Ultrabase because I don't need to use glue stick. I can use just raw Ultrabase or nanopolymer that I hardly ever have to do anything to. Just wipe the dust off and you're good to go. With the PEI, you have to put glue stick down, otherwise you're going to ruin it. Okay, so those two, the Ultrabase wins in my book. And then here for ABS, we can see lots. I mean, every single one of these was a successful print. I'm going to call these successful. I didn't see any, you can see their shine there. I didn't see any bit of peeling, which really surprised me, because in the beginning, when I first started 3D printing, most of the peeling problem I got was when I was printing with ABS here. So it was really surprising to me to be printing in the open air and to get such success. Now, that's not some magic thing, though. You can't just go, oh, I can print ABS. First of all, ABS is very stinky. It'll poison the air in your room that you're printing. And second of all, as you print taller, so these were just very short, look at how thin that is. Very short prints. So as you print taller, those same cooling forces are happening inside of your print, and so you get layer delamination. So your print, at the edges of the print, the one layer it starts out stuck down, and then as it cools, it actually peels up off the previous layer, just like it would peel up off the bed. Well, these beds at 110 degrees were able to kind of not let the, the polymer, the ABS polymer, they didn't allow that to fully shrink, because 110 is pretty hot bed temperature. And so that's why we use heated beds. So anyway, yeah, ABS, if you're doing a short print, any of these things will work. But again, I prefer build tack. Build tack with nanopolymer popped off quite nicely. Not build tack, excuse me. What is it? Ultrabase with nanopolymer. It popped off quite nicely. So that's where that is. That's my decidedly unscientific study that, kind of my judgment based on how easy things were to peel off. Although we could see these things peeling up off the bed to begin with. But there's room here for sure to quantify and make like an Excel spreadsheet or something of all materials, and to really standardize the test, to do it more rigorously, like in a scientific method. And I'm looking at you, Stefan. This might be a good video for you to make there. You're the expert, engineer over there. I'm just a designer here, hacking through all this. All right, let's talk about the history of adhesives, because I kind of want to talk about what is this? Kapton tape and maybe some masking tape too. All right, let's talk about a little history. So, in the beginning, a guy named Dr. Adrian Boyer, basically started the rep-rap movement because he saw how expensive Stratasys machines were, and he was like, I could do this for a whole lot less money. Now, Dr. Adrian Boyer, I'll put it in the description. There's a great video by Tom Sandlotterer with him in it. And basically, he's a jack of all trades as far as like robotics and programming and mechanical engineering, all that kind of stuff goes. So his graduate student was named Dr. Ed Sells, and well, he wasn't a doctor yet, but Ed Sells created the Mendel printer. The Mendel became the Prusa Mendel, aka the Prusa Mark I, and then the Prusa Mark II and the Prusa Mark III. These are all Mendel printers. So Prusa did not invent this style of printer, despite what the internet wants you to believe. And the thing is that the original Mendel, here I'll show you guys a picture. The original Mendel used a wooden bed with masking tape on top. So that's crazy, right? Obviously that was not a heated bed. That was a, just a regular bed. So they were printing with PLA. There's no way they were printing with ABS. And there were only two materials in the beginning. Those were the two filament types that Stratasys sold, and that was ABS and PLA. And obviously there weren't any filament manufacturers yet because Adrian Boyer was making the first Arduino run, 3D printers anyway. So yeah, all this stuff came later, and then the first printers used just threaded rod, like M8, metric 8 threaded rod, like your bolts. And that's not ideal. And then we eventually got lead screws coming from China. All this is kind of cheap stuff that ended up coming from China. So thankfully, China does exist. It's just the copycatism that's bad. There's a balance in there. China just copies too much. But anyway, blah, blah, blah. So back to the Mendel design and weight. Okay, so this is very important. This bed here, this Ultrabase, I showed you guys how heavy it is. And on a Mendel printer, that really matters. You see how it's constantly going back and forth? This is called inertial mass. This manifests on your prints, causes lower print quality because of ringing or ghosting. So Mendel printers, including the CR10, the artillery sidewinder, the Prusa, all of the Mendel printers are the inferior frame design to Core XY because Core XY, the bed drops very slowly and you don't have all this weight of the bed moving. Now Prusa does, to his credit, make a pretty lightweight bed. It's just that the Garolite, the stuff that I showed you, this the PCB surface with an actual PCB heating element on the back of it. And then you've got the pretty lightweight, thin, flexible, spring steel with the PEI coating. So yeah, that's a pretty lightweight bed. So kudos to Prusa for doing that. Your Chinese printers all have PCB bed on an aluminum substrate. Now the aluminum is nice because it disperses that heat and you get a more even heating pattern. And Tom Sandlotterer again has done bed heating thermal analysis. So probably superior to the Prusa design because you get better dispersion of the heat. But still, I don't think either of those is good because I don't really like waiting for my print bed to heat up. And so I like the original solution, which came after the unheated, the one I just showed you, the Sells Mendel printer with the wooden bed. After that, they started heating beds and they were using these silicone mats. This was pretty much the original solution. So this is just nitrile wire embedded in silicone. So it's flexible enough, and silicone is a really high temperature rubber. I think you can get to like 600 degrees before it starts to fail, and there's no way. I mean, even our nozzles don't get to 600 degrees Celsius. So I think we're doing okay with these. So yeah, I love this solution. I do. This is a 110 volt AC bed. It heats up like that so fast. And it plugs directly into the mains voltage, which means that you don't need as beefy of a power supply to also be powering the bed. So you can save on your power supply and get a more efficient power supply because all it needs to do is heat up the nozzle and run the electronics, and the electronics are negligible. So I actually think that this is the better solution that everybody should be at. And you can get these for really inexpensive these days from China. Of course, they're still more expensive than PCBs, but this is one place where I don't like the way that the industry followed Prusa in the, Prusa invented, well, he didn't invent anything, but whatever. Prusa pioneered the use of PCB bed heating. And it's just because it's inexpensive. This is the superior solution. I wish that all of my printers came with this, and only 2 of them did. I've got the artillery sidewinder and my, what is that one? The Tevo little monster. Those both came with this, and I love them. I love them. So, yeah, this was the next thing that they did, and they started using borosilicate glass with that kind of a silicone bed. And so the borosilicate glass, the obvious evolution of this is Ultrabase. And so this to me still the most ideal, just because it works as well as the PEI, and it's so flippin' durable. Like, you can't, I've never even broken, oh, I take that back. I did break one. I got one of these made and cut at my local place for use on the Tevo little monster, because whatever, I was doing experiments, and I heated it way up and then cooled it way down. I was really abusing it, and it was the heat cycling, and I don't think I got the right glass to begin with. So yeah, that's the only glass bed I've ever broken, and it wasn't one that came specifically, sold to me as a 3D print surface bed. So, yeah. So the next thing, of course, they were trying to get, you could get PLA to stick just fine to borosilicate glass with the bed heater, especially. Although you don't even need a bed heater, PLA will stick without a heater. But with the bed heater, you were starting to get ABS to stick to it okay. And then they were starting to put masking tape down again. Now you saw the masking tape on the original Sells Mendel there, but the masking tape was really, they were trying to keep the peeling from happening with ABS, and it has a great tooth on it, right? The surface really takes the masking tape quite well. Really takes the print quite well. The problem is that the glue here of the masking tape is not a high temperature glue, and as the bed heats, the masking tape lets go of the glass. So you would still get peeling, even though the ABS was sometimes you could not even peel the masking tape off the bottom of the ABS. It was so stuck on there. But the tape itself was peeling, so it still would fail. And the next thing they went to was this Kapton tape, and this stuff is some fancy polyimide. It's a polyimide film. There's a cool history to this, although apparently it killed a bunch of people. This is responsible for an airplane crash. Yeah. So, but it was used in the Apollo space missions, and it was supposed to be this wonder plastic because it's so high temperature, and the adhesive on it also, pretty high temperature stuff. But yeah, it fails for electronics, so probably not ideal for your electronics products. But who am I? I'm not an EE. So, to me, though, and in my decidedly non-expert opinion, I think that it's just incredibly similar to PEI. Look at how these are similarly colored, right? Similar color. And I think it's hard to get this stuff in a thick film. I think it has to be this thin film that it comes in. I don't know. I've never seen it thicker than this. Polyimide. I should go looking for some specialty shop. But I don't know why we went with PEI instead of this when this was working. It's an interesting jump to go straight to PEI. And when I first started experimenting with PEI, I got a 16th inch thick. It was a really thick piece from McMaster-Carr. And now, of course, coming from China once again, you can get those thin films. And they're made just for us, just in the 3D printing. We're the ones that drive the industry to supply the thin version. Before that, McMaster-Carr was selling them to machinists for some reason. And that's why the thick one was the only one that was available. So yeah, again, thank you, China, for supplying all these cheap parts to us, lead screws instead of threaded rods and thin PEI. China is great. It is. China is great. The thing is that China needs to work with the West and respect intellectual property. If a Western person develops it and then wants to bring the manufacturing to China, yeah, China deserves that cut for being the manufacturer. But they shouldn't be trying to cut out the original creator. And the reason I'm talking about this right now is because nanopolymer adhesive, the stuff from Vision Minor, is awesome. And I talked to these guys, and they're really friendly, and they told me the story where basically their core business is printing high temperature plastics, PEEK, Ultem, polycarbonate, that kind of a thing. And they were having bed adhesion problems, so they hired the expert of experts. We're talking an adhesives engineer maybe like the guy who invented the Post-it note glue, that kind of a thing. Like the guy costs $500,000 a year to employ. He's not cheap. And so they paid him for his time to develop the ultimate glue for print surfaces. And this is what he came up with. So how much did they end up spending on this guy? It wasn't cheap. And so they have to charge $50 a bottle, which that's expensive. But that's because they're trying to recuperate the costs of, employing the guy who is the expert. Now China comes along and they stick this in a spectrometer or somehow, and they might be able to reverse engineer this, and they can start selling it for like $2 a bottle. And so they basically are cheating because they didn't do all the experiments to know why this is the best, or to know what all the other failures are, all the other versions that they could have done. They go straight to the right answer because they're looking at the test questions from Vision Minor. It's insidious. It's so evil. So once everyone in the 3D printing industry realizes that you cannot make a product and make a profit, why are you going to try? Like, why are you going to try? I have ideas for 3D printers. I have actually had a successful Kickstarter. I have a patent, and I will never, never try to bring a 3D printer product to market unless I can find some strategic advantage to cut China out, because I know China's just this wolf pack of like predators waiting to copy me and cheat off my answer. So I'm not going to spend the time. I'm not going to do it. And all the other engineers are maybe smarter than me. They're not going to make that mistake either. I'm surprised that Vision Miners made this. Hopefully they can hang on to their secret formula and recuperate their money. They deserve it. This is actually a really good product. And I'm convinced it's this that makes your Ultrabase so good. Now the Ultrabase is better than your borosilicate glass, although I need to do an experiment and see just how good nanopolymer on borosilicate versus nanopolymer on Ultrabase would perform. But anyway, blah, blah, blah. Bottom line is, I love this stuff. Ultrabase with this stuff is my favorite bed for sure, and I can give you some of this. That's right. So Vision Minor, cool company. They're allowing me to give away, I think, 2 or 3 of these. So chime in the comment down below saying, I want free stuff. And so in a week's time, everybody who said, I want free stuff, I will go through and randomly select like 2 or 3 of you guys, and Vision Minor will send you a bottle of their product, which is awesome. So thank you for watching. See you next time.